Hello everyone. We will be discussing the customer churn prediction using deep learning models. Uh, Customer churn is a significant issue in the telecommunication industry where business aim to retain their customers for as long as possible. The goal of this project was to predict customer churn using deep learning models based on customer profiles, services used, and payment information. The ability to accurately predict churn allows companies to take proactive measures to retain at-risk customers, leading to improved profitability and customer satisfaction. For this, we use the telco customer churn dataset from Kaggle, which includes 7,043 customer records and 25 features. Key features includes customer tenure, contract type, payment method, and monthly charges. The target variable is churn, indicating whether a customer has left the service or stayed. The dataset is moderately imbalanced with about 26% 500 of customers labeled as having churn. To ensure data quality, we performed check through for missing values and ensure the features were suitable for analysis. We did the analysis using four main deep learning models: ANN, CNN, RNN, and LSTM. We used mainly four pre-processing techniques: encoding categorical variables, scaling, handling imbalanced data, and train set, test, split. Here in the pre-processing unit, we have first load the data set, then drop unnecessary columns, then handle missing values, then convert categorical features into numeric, uh, then normalize the numeric features, and split data into training and test data sets. First, I will be discussing about the ANN architecture deep model. Um, this includes four main layers: input layer and two hidden layers with 64 and 32 neurons, and output layer. Here first I have imported the necessary components. Then I have defined the ANN model here and compiled the model and train the model and collect and store it in a variable named history. And this in this code part I have analysis the model loss and model accuracy. As you can see, the model loss will be decreasing and model accuracy will be increasing with the number of epochs. Here I have implemented the heat map of weights in first dense layer. And this model has an accuracy of 0.81%, 81 and loss of 0.41. That's the ANN model. I will invite Shabri to discuss the LSTM model.
Thank you, Mindali. Uh, I will discuss about LSTM model. First, I import the necessary. First, I import the necessary modules from TensorFlow and Keras. And LSTM networks expect input data to be in a 3D shape, so we reshape our data accordingly. And we define a sequential model and add layers. And we compile the model with the appropriate optimizer, loss function, and matrix. and we train the model using the training data. Finally, we evaluate the model performance on the test data, and I will get accuracy. The accuracy of the LSTM model is 81.69%, and we plot the training and validation accuracy and also epochs to visualize the model's performance. This is the accuracy plot and loss plot, confusion matrix plot, plot, and we generate and plot the confusion matrix to evaluate the classification performance. So these are the graphs, accuracy matrix, and model accuracy and model loss. And so we successfully built and trained an LSTM model to predict customer churn. We have covered data pre-processing, model construction, training, and evaluation. Visualizing the result help us understand the model's performance better. So that's all. I will invite the Dhananjay to continue.
So my part is CNN architecture for customer churn prediction. So the CNNs are commonly used for the image data, but they also can be applied to structured and tabular data like customer churn prediction. So by reading the input features as sequence. So this is my coding part. So first of all, I have to import the necessary libraries like pandas, keras, matplotlib library. So likewise, and after that, I have to load 10 pre-process the data set that import in the CSV file, uh, customer column data. So likewise, and after that, I have to encode the categorical variable like label encoder, categorical columns, that the list contain the name of all the categorical columns in the dataset that need to be the encode. So after that, I have to split the features and targets. In the first line, used to remove the target variable from the data frame and assign the remaining columns to X. And the next column used to the target column is assigned to the Y. That target columns contain information on the whether customer has churned or not. So after that, the coding part shows the normalize the features and split into the training. It's split into training and the test the data. So in that test the data, I have to test. I assign the test. I assign the test size to 0.2 and random state to 42. So likewise, so after that, we have to reshape the CNN inputs. Like reshaping the resharpen the input data for CNN, and after that, we have to model the model our CNN, and it's contained at the convolution layer, flatten layer, dense layer, output layer, likewise. And after that, train the CNN model with the validation split. So it's in the CNN model training. The training parameters is the Y-train, X-train, resharp, epochs, batch size, validation split, callbacks, likewise. So in the end part, we have to evaluate the test data using this command, and after that, print the test loss and accuracy. So you can see in this table our accuracy and precision, recall, support, F1 score likewise. So the visually representation shows this coding. So you can see the model accuracy that are training accuracy and validation accuracy. So it going to down to up, and this is model loss. So you can see it is going to high to low level. So that is my part, and I invite to the Jai Singh to continue this.
Thank you, Banga. I am Jai Singh, JAMP. Firstly, I use recurrent neural network, which is useful for time sequence data, but can also do sequential tasks like prediction. Uh, in this model has 4 layers: input layer, simple RNN layer, and dense layer and output layer. In this extend reshape is the input is reshapes the original data. The purpose of using this is feeds data into the recurrent layer. Each sample is a time series like input where the RNN processes one step at a time. The one is a simple RNN layer. I use a neuron 64 units as a neurons, and each unit is a recurrent neuron, meaning it takes it to count the current input and the previous state. And I use ReLU as activation function. It helps the network learn complex pattern by introducing nonlinearity. And I use L2 regularization also, and it helps the network learn. It helps to reduce the overfitting and ensure better generalization. And second layer is a fully connected dense layer. In this, I use 32 units and neurons. And I use ReLU as an activation function and L2 regularization also, and it's also fitting by penalizing high weights. And I use dropouts for another 50% dropout rate is applied after this layer. And other ones is dense layer, it's output layer. I use 1 unit and activation sigmoid use as an activation function. It converts output into a probability between 0 and 1, which is useful for binary classification. What is the training model? I got these graphs, model accuracy and model loss. After the train these 4 models, we compare the accuracy between these 4 models. You can see the graph of accuracy comparison.